So it says when an extension ladder rests against a wall, it reaches 4 meters up the wall, right? 4 meters up the wall. This is actually the original position of the ladder I'm showing you. This was the original position of the ladder that actually like one end is attached with the wall, right?
Yeah.
This one. The ladder extended a further of 0.7 meter without moving the foot of the ladder. Without the foot moving, like 0.7 meter further. Without moving the foot of the ladder, it now rests against the wall 1 meter further up.
Yeah.
What does it mean? There is actually a new ladder. Its length is 0.7 meter longer, right?
Yeah.
Because you didn't change actually the foot. So it means this ladder, the new ladder, should be longer as compared to this red one.
Yeah.
And you can see its position as well. Find the length of the extended ladder. So extended ladder should be the previous ladder, like it is x, it should be x plus 0.7. Got it?
Yeah.
So to find it, we have to find the value of x. Clear?
Yeah.
Yeah, I'm going to use the Pythagoras theorem here.
Okay.
If I say this length is equal to y, right? This length. And I'm just labeling this with A, B. This point is B, right? And this point is C. And this point is D. So I have a pair of right angle triangles. Got it? I'm making here. What we need, the length of the extended ladder. So we need actually this length. Clear?
Yeah.
Okay.
Yeah.
So I'm using the Pythagoras theorem on both of the right angle triangles one by one. So using Pythagoras theorem, on which triangle? The smaller one, that is ABC, right?
Yeah.
So according to the theorem, it is hypotenuse square is equal to opposite square plus adjacent square. So which length is the hypotenuse? X, because it's opposite to the 90 degree. So hypotenuse is the length that is opposite to the 90 degree, the larger in all, right? So it is X. So X square. Yeah. Opposite side, we can say it is 4. And adjacent side is Y. Clear?
Yeah.
Similarly, I'm applying the Pythagoras theorem on the larger right angle triangle. PT for the Pythagoras theorem on triangle ABD. Got it? And this time the hypotenuse is this length, it is x plus 0.7. Opposite side is what? Opposite side is less length for this triangle. Got it?
Yeah.
This we are actually taking this triangle. The opposite side is 1 plus 4, 5. 1 plus 4, 5, right?
Yeah.
And adjacent side is y again. And you need actually x. So we have x in both equations, but we have to get rid of these y as well. So it's very easy. Just simplify this, it becomes 25 plus y square. And we can open this as well. It's a plus b whole square formula. A square plus 2ab plus b square, right?
Yeah.
What is a here? X 0.7 and this is 0.7 as well. Got it?
Yeah.
So we get x squared plus 0.7 into 2 is 1.4x. And this will be 0.7 squared is 0.49. Shifting this 25 as well, it becomes negative 25, and we're left with y squared on the right-hand side.
Yeah.
We can simplify this further. X squared plus 1.4x plus minus, I'm using my calculator now. It is 0.49 minus 5. Got it? Sorry, 25.
Yeah.
So I get this, minus 24.51. It is equal to y squared. Got it? Similarly, shifting this 4 square to the other side as well, so we can have y square on the right-hand side of this equation as well. So x square, what is this? 4 square is 16, so it becomes negative 16 there.
Yeah.
So you can see this equation, the first one and the second one. Both equations are equal to y square. Both expressions, this expression and this expression equal to y square. So we can compare these equations, right?
Yeah.
Like comparing 1 and 2. We get this side should be equal to this side. Got it? Because both are equal to y square. So x square minus 16 will be equal to x square plus 1.4x minus 24.51. Clear?
Yeah.
This x square and x square can be cancelled like this. X square minus 16 minus x square, shifting all of these terms to the left. And we are left with 0 on the right-hand side. So x square and x square cancelled. So what we have, shifting this term, so it becomes positive there. So minus 16 plus 24.51. And on the other side becomes 1.4x positive. Got it? So now you can see we have only a linear equation of one variable, and we can find x by it. Okay, minus 16 plus 24.5 gives you what? Minus 16 plus 24.51. It's 8.51, right?
Yeah.
1.4x. Now shifting this 1.4 to the other side, it will obviously divide this. So this is the length of, this is actually x, 6.08.
Yeah.
So what was the length of the extended ladder? It's x plus 0.7.
Yeah.
So the length of extended ladder LADD, it is x plus 0.7. So we get 6.78 in meters or centimeters? In meters, right? Okay.
Yeah.
You can note this. Okay, next part is the increase in the angle that the ladder makes with the ground now that the ladder is extended. So what is the difference actually? What is the increase in angle? First of all, we should find the angle of the previous ladder, the red one, right? So, and then the angle that makes with the ground, the ladder second actually makes with the ground. Then we can take the difference between these two angles to find the increase in the angle. Got it?
Yeah.
So I'm doing part B here. Yeah. We need basically this angle in part B. So I'm going to find first, angle this smaller angle, and then I'll find this one as well. Got it?
Yeah.
And then subtract the smaller from the larger to get this red angle. Okay. So how to find the angle? Obviously, we should need the trigonometric ratios because we have lengths.
Yeah.
Clear?
Yeah.
Okay. I have 4 and x. So these lengths are opposite and hypotenuse. So that's why I'm using sine. So
Yeah.
in triangle ABC, sine angle is what? The angle is BAC.
Yeah.
It's equal to the opposite side over hypotenuse. What is the opposite side? It's 4. The hypotenuse is x. What was the value of x? X was 6.08, right?
Yeah.
So angle BAC will be sine inverse of 4 over 6.08. Got it? Okay.
Yeah.
Using my calculator. Four over 6.08. So I get 41.1. Got it?
Yeah.
Then I'll be finding this angle as well, BAD. So for this, I'm using the larger right angle triangle, which is ABD. Again, I'm using sine angle BAD. And the sides are opposite. Opposite side is 5. And hypotenuse is x plus 0.7, which is 6.08. We already found, I think. Yeah, 6.78. So
Yeah.
angle BAD will be equal to sine inverse of 5 over 6.78. So I get 36.2, right?
Yeah.
So now I'm finding the difference or increase in the angle. It will be difference, obviously, 41.1 degree minus 36.2. So I get 4.9 degrees. Clear?
Yeah. Yeah.
Done?
Yeah.
Okay. It says you are standing on a coastal cliff 400-meter high and have a look for 35-degree down from the horizontal to see the boat.
Yeah.
So I'm just actually making this scenario for you. Wait, say this is actually the cliff. And here it's like some sea or something, right? So
Yeah.
here we have a boat, right?
Yeah.
And you're standing on the coastal cliff 400-meter high. Say I'm just standing here, for example. Got it?
Yeah.
And I'm watching the boat 35-degree down like this. with the horizontal, down from the horizontal line. Where is the horizontal line? Horizontal line is here. This is horizontal.
Yeah.
Yeah, this one. So this 35 degrees is actually angle of this board with the horizontal. Clear?
Yeah.
How far from the cliff base is the board? So this is actually the cliff base if we complete the right angle triangle out of it. So we need this length. Clear?
Yeah.
This is the base and this is the board, and we have to find the distance between base and the board. So if I say it is X, I need X. 400 meter high, so this length will be 400 meter. Clear? So if I convert it to right angle triangle, this is a right angle triangle, you can see that we have a right angle triangle, this one. In which we have one length. What is the angle of this right angle triangle? Because we need at least one angle to find the length of this, right?
Yeah.
So you can see these lines are parallel. So parallel means if it is 35, this should be 35 as well. Why? Because they are alternate angles. Got it?
Yeah.
So this should be 35 as well. Because they are alternate angles of the parallel lines, as this is a transversal. So now we have a right angle triangle in which one angle is 35 degree, one side is given, where it is 400 meter, and we can find the second height by using the trigonometric ratio. Got it? So
Yeah.
which ratio should be used here? Opposite side, adjacent side, tan.
Done. Yeah.
So tan 35 is equal to the opposite side, which is 400. Adjacent side is x. So shifting this x to the other side becomes x times tan 35 equals 400. Now shifting this tan as well. So we have x is equal to 400 over tan 35. Got it?
Yeah.
So we're calculating it, 400 over tan 35. 571.26 in meters. So if I write in 3 significant figure, this will be 571 meter approximately, right?
Yeah.
Done?
Yep. Done.
Like when we have this type of question, like question number 7, how to solve it. From the top of the cliff, 250 meter above the sea level. So this is actually, this length is 250 meter, right?
Yeah.
The angle of depression to 2 fish. What is the angle of depression? Angle of depression, if you are standing on the top and you are looking at down side, like
Yeah.
so the angle that makes this B1 with the horizontal line, that is called the angle of depression. So horizontal
Yeah.
line is this. This is the line of sight. Got it?
Yeah.
So this angle is actually angle of depression of B1, and this angle is angle of depression for the B2. Got it? The depression, the first angle is 16.3 and the second is 21.5. So obviously this angle is smaller, this angle.
Yeah.
Which one is smaller? Obviously this one. So I'm writing here 16.3. And this angle is obviously 21.5, which is the larger angle. Okay. So we're telling that these are the angle of depression, 16.3 and 21.5 degrees, right? So how far apart are the boards? So we need this distance. Got it?
Yeah.
Okay. I'm making this diagram again.
Wait, what distance do we need?
B1 to B2.
Okay. Yeah.
Making a diagram again for the clarity. These are the positions of the boards, B1 and this is B2, right? Okay, this point is the peak. This length is given 250 meters. Say say this is A, right? Okay.
Yeah.
Now I'm showing the angles. This is the line of sight, obviously, and the angle of depression will be, first is this, and the second one is this. First is 16.3 degrees. Second one, this angle is 21.5 degrees. Got it? Again, these two lines are parallel to each other. Which one? This and this. So that's why this angle must be equal to 16.3. And similarly, this angle must be equal to 21.5. Got it? Alternate angles. What we need this length. Okay, so how to find this length? This is actually the part of the base or adjacent side of this right angle triangle, because this length, this angle is 90 degrees. So we have two right angle triangles. First one is PAB1 and second is PAB2. Got it?
Yeah.
So if we find this length and then this length, got it? And subtract this length from this, we'll get the value of x. Clear?
Yeah.
So I'm going to find AB1 by using the Pythagoras, by using the trigonometric ratio. Got it? So in triangle, the first one is AB1. In triangle PAB1. This length is obviously adjacent side and another side is given, which is opposite side. So that's why I'm using the 10. Angle is 21.5. This is 5 only. 21.5 degrees. Got it? So 21.5 degrees equal to the opposite side, that is 250, over adjacent side, that is AB1. Right?
Yeah.
So shifting this AB1 to the and this 10. So they can be interchanged. So AB1 will be equal to 250. I mean, the position will be interchanged. Over 10, 21.5 degrees. Got it? So this is AB1. I'm not calculating it right now. Similarly, we can find AB2 as well. But this time I'm going to use the larger triangle to find this length. So which is PAB2, right?
Yeah.
Again, using the 10, but this time the angle is 16.3 because this triangle is used here. Got it?
Yeah.
So opposite side again 250, but the adjacent side is AB2. Right? So again, interchanging their positions, AB2 will be equal to 250 over 10, 16.3 degrees. Got it? So this is AB1 and AB2. Obviously, it gives you a numerical value. But what we need, B1, B2 or X. So X is equal to AB2 minus AB1. Clear?
Yeah. Yeah.
So inserting the values, AB2 is 250 over 10, 16.3 minus 250 over AB1, 10, 21.5. Got it? So now you can use calculator to simplify this whole expression at once. Thanks, 250 over 10, 16.3. And minus 250 over 10, 21.5. Got it?
Yeah.
So we get 220.27. So x is 220.27, obviously in meters. In three significant figures, this value will be 220 meters almost. Clear?
Yeah.
Okay, it says a tower 42 meters high stands on a top of a hill. Okay, I'm making a hill first. Say this is actually the hill. And a tower standing, its height is 42 meters. Say this is the tower. Right?
Yeah.
Its height is 42 meters. I'm mentioning here. From a point some distance from the base of the hill, the angle of elevation to the top of the tower is 13.2. So this is actually the base. And a point, say, there is a point, right? 13 point. Yeah. Say this is the point, I think. Yeah. From, if we're standing at this point, like this point, and if I look at the top of the tower, then the angle made will be 13.2. That is actually the angle of elevation with the horizontal line, right? So I'm making this angle. So this angle is actually 13.2, right?
Yeah.
The angle of elevation to the bottom of the tower with the bottom, this is the bottom point, is 8.3 from the same point. So I'm making another line, the bottom of the tower, right? And this angle is actually this blue one. This angle is obviously smaller. It is 8.3 degrees. Right?
Yeah.
So what we need, find the height of the hill. So height of the hill is obviously this.
Yeah.
So we need this h. Right?
Yeah.
Nothing is given except this 42 length and 2 angles. Okay, so if I say this length is, this length is x. Got it? So I can involve this height in this right angle triangle. If I like, I'm saying it is A, this is B, this is C, and this point is D. Got it? So I'm using ABD triangle and find the value of x, because x is common in both right angle triangles. So I can compare those values of x to get the value of h. Got it? So I'm writing here in triangle, the smaller one. This is the right angle triangle, DAB. Tan angle, what is the angle? This blue one, 8.3.
Yep.
Equal to the opposite side. Opposite side is h, opposite to the angle, right?
H. Yeah.
Over adjacent side, that is x.
X.
And in the other right angle triangle, that is CAB. Again, using tan because these two sides are involved. So tan angle is larger this time. For this triangle, that is 13.2. Again, the opposite side is this whole side. This is 42 plus h over adjacent side again x. Got it? So you can see in both equations we have the values of x. Yeah?
Yeah. Why is it 42 plus h?
Because the triangle I'm using it is this. This is the triangle, the large one.
Yeah, okay.
So opposite side is obviously 42 plus h.
Yeah.
Okay, so we have x because we need h. That's why I am making x as subject in both equations. So taking this x to the other side will obviously multiply with 10 like this. Now dividing this 10 to the like both sides, and we get x equal to h over 10 8.3. So we have made x as a subject. Similarly, we could do the same with the second equation. Taking x to the other side, it will be x times 10 13.2 equals 42 plus h. Got it?
Yeah.
And then take this 10 to the other side, so it will be x equal to 42 plus h divided by 10 13.2. Say this is equation 1 and this is equation 2. Now we can compare these two equations. Means if it is x equal to this and x equal to that, so the right hand side should be equal to the right hand side of the second equation. So I'm writing here comparing 1 and 2. So right hand side from the first is h over 10 8.3, and from the second the right hand side is 42 plus h 10 13.2, right?
Yeah.
So what we need h. So I'm going to do the cross multiplication here. So after cross multiplication, what I get h times 10 13.2, and what it becomes 10 8.3 will multiply both of them, so it will be 42 10 8.3 and plus h 10 8.3. Got it? So to make h as a subject, we need to combine the terms that has h. So that's why I'm shifting this term to the other side, to the left hand side. So what I have after shifting it is h 10 13.2. This will be negative h 10 8.3 equal to 42 10 8.3. Got it? Now you can take h as a common, and the leftovers will be 10 13.2 minus 10 8.3. Clear?
Yep.
And this will be 42 10 8.3. Okay. We can separate h now by just shifting this whole thing to the other side. Obviously, it multiplies by h here, so it will divide the whole expression of the right hand side. So h will be equal to 42 10 8.3 divided by 10 13.2 minus 10 8.3. Got it? So this is actually h, and we can calculate this whole expression by using calculator. It's 10 13.2 minus 10 8.3. So I get 69.11.
Yeah.
And in three significant figure, obviously, it is 69.1. And the unit will be meters, in meters, yeah. So this is h. Got it?